Hello, welcome GSoC interns and other people. Thank you for watching this streaming of the Liquid Galaxy community. So today I'm here at the Lleida Liquid Galaxy Lab, headquarters of the Global Liquid Galaxy project. And with me are the Liquid Galaxy and Laboratory interns from Lleida. Say hello.
Hello.
They are alive. They seems to be not, but they are alive, believe me. And then also I want to say first that we have one of our interns, that case Oscar, that suddenly has have a personal problem, and we wish him soon to get well. So let me say this phrase. Let's repeat. No, it's clear. They say, Oscar, get well soon, because Oscar is having some trouble with his personal health. So Oscar, get well soon. Today's presentation is going to be the midterm presentation for the Liquid Galaxy Lab in GSoC this year, 2024, and we are going to have 12 presentations of the different interns, and with the help of colleagues from the laboratories, the interns will introduce you to the project in a short video, we hope. Then they will make a short presentation in their homes or in the Liquid Galaxy they have, whatever place they're in the world. And then also, if it's available, we will also make a short demo here at one of the many Liquid Galaxy rigs we have in the Lleida laboratories. So this is it. I also want to say thanks to our very huge global team. We are more than 60 persons this year working on the GSoC, from our enormous Google Developer Expert, Google Test Maker, DDG leads, and many different experts on different technologies that are helping to the different GSoC contributors to be achieving their projects. To many other colleagues that are reviewing the applications, reviewing the code, reviewing the documentation, and so on. So thank you everyone for collaborating, and we hope to enjoy this stream. Thank you.
Hello, my name is Ryan Kim. I'm currently demoing my Liquid Galaxy project so far for the midterm review for GSoC 2024. And a brief overview of my project, I'm currently implementing an API where users can integrate voice-to-voice features for their application. So there are three endpoints mainly that users can use. One is speech-to-text, one is text-to-speech, and one is the Groq. So speech-to-text allows users to pass in audio files, and they can choose between various models and optional parameters to customize for their needs, and it will get back a text response that they can use for the application, as well as there's also a text-to-speech endpoint where users can pass in text, and then depending on which model again you select, as well as the optional parameters, it will get back an audio file, so they can also play that for their application as well. As well as we have the Groq endpoint, which utilizes the Groq API, and there's a lot of LLM models that they can pass into, and it'll get back a text-to-text response, and they can use that for the application as well. So if you just switch over here. So this is just to test our API out. So I'm making a post request to one of our endpoints, which is going to be speech-to-text. Okay, and then we're going to pass in a model. So for the model, I'm going to just go with one demo, Google speech-to-text, and then for the audio, I'm going to pass in a file, and if we select a .wav file, this is an example .wav file, I think it's around 20 seconds long, and if we send a request, it'll take just a second, and what we're going to get back is it's going to use the Google Cloud speech-to-text model, and we're going to get back a response through text. And here we go. There's the transcript of the audio file itself. So here's a sentence. As well as if we demonstrate the other API endpoint, there's also text-to-speech. So we'll pass in raw JSON. And so for the model, again, we're gonna just demo the Google model. So I'm gonna copy paste this and just switch to other way around, text to speech and content. And for the content, I'm gonna pass in just, let's say, hello. How are you doing? Yep. And if we send our API to that, it will take a bit. And here's our generated audio file. I'm gonna try to play it.
Hello, how are you doing?
Yeah, so there we go. We get back a response. And then last but not least, we're gonna have our Groq API endpoint. So for Groq, I'm just gonna grab one of our models. I'll go over this documentation just a bit, but let's use the one of the Google GEMMA models. So I'm gonna go back to API for a model. I'm gonna store in the model, and then the content, I'm just gonna leave it the same. We can just ask the model, hello, how are you doing? We're gonna get back a response, and then it's gonna say, as an AI model, I don't have any feelings, etc., etc. So these are the 3 endpoints. So what I've done is I have a API documentation. So it's Dockerized, it's easy to set up for all the users, as well as instructions on how to get all their environment and keys set up, and then as well as different endpoints, as well as I have a description, documentation of the description of all the models that I am currently using. So for like speech to text, there's various models, and then it's text to speech, as well as the Groq, and it also has all the optional and required parameters, so users are able to customize however they want to use the application, and kind of tweak around a bit to see what best fits their needs, as well as also have a pricing documentation to ensure whatever model they go with is the best for their needs. And yeah, it's a brief demo of my project, and thank you.
Hello everyone, my name is Mahinour Elsarky from Cairo, Egypt, and I'm very happy to be here today presenting my application with Liquid Galaxy for the second time in Google Summer of Code 2024. So I'm here today to talk about the project briefly and show you a little demo about the status of the app so far in both the tablet and the LG. So let's start. So my project is AI Touristic Information Tool for Liquid Galaxy using the GEMMA model locally. So the application is to show the users, for example, if any user wants to be in a certain location, in a certain city, a country, and wants to know any activities that can be done nearby, or for example, best restaurants nearby, or for example, he wants to know activities globally in the whole world, or for example, landmarks in the whole world, or so on. So he can use this app to help him see the places he can visit. So the app uses the GEMMA generative AI model from Google, and I'm using it locally. So let's start with the demo and see more information on how this works. Let's start. So now let's start opening the app together, as we can see here. And then when the app opens up, this pop-up message appears that state that AI models sometimes give hallucinations. And of course, the first thing that we should do once we start the app is go to the connection manager. So now I have entered my data for the LG connection. Now connect to the LG. We can see that it's now connected to the LG rig. Now let's do the same with our AI server. So let's connect. And it's connected. So in our home page, there are 2 options for the user. Either to explore worldwide or explore certain location and explore places or any activities he wants to do nearby that location. We also have here most popular activities worldwide. So we have those 2 you can choose from. And we also have here if the user want to write anything to the GEMMA model. So now let's start with, for example, choosing one of the saved ones. So now we have here the balloon showing the place and the query or the thing we're going to see. And here we have the list of points. So here we asked for attraction in London, UK. So here we have the list of 10 points of London attractions. And we can see, for example, here we can fly to a location. So we have the experience of the Google Map and Google Earth together. So if a user doesn't have access to Google Earth or an LG rig, he can experience the same with the Google Map. We can see that we have also the similar balloons here and here. We can see also here the data, and here too the rest of the data. And we can see the place mark in the map, both of them, and we can orbit too, but the orbit is only on the LG rig. We can close the orbit, and we can clean here the balloon, and we can see all points. Note too that here we have a synchronization between both of the maps. So for example, if we moved here, it's going to sync with it and move with it too. So if we zoomed in, it will zoom in too. And note here we have the balloon too of the 10 points. And let's close. When we close, it's going back to the home page. Now we have seen here in the worldwide, exploring the worldwide, we have seen a saved prompt. Now let's try with an unsaved prompt and see what the model will give us. So for example, let's choose one of the unsaved prompts. For example, here, let's see what happens. So first we have this processing screen with a progress bar or a progress for the user, because this takes some time since I'm doing it locally now. Let us wait for a while for the next step. Now we can see that it's streaming, and we can see that it's streaming in a JSON format, so it can be in a readable format for the user. As we can see, it has finished and it shows end of chain. After the model finish, we can then press on the Visualize Now button to visualize like we have done before with the London Attractions Tour. Let's press on the button now. So we can see that the visualization dialog appeared too, and it shows here too on the LG. Those are the locations that the model output. Okay, so let's explore the certain location tab. For the exploring the certain location, we have the following buttons. So let's just clear the balloon from here. For example, I'm going to show you that if we choose an address, it shows here the name of the place, and then AI recommended things to do in this place, like here. And we can also type in the text field what we want to do or search nearby this place. So for example, let's go on here and type an address. For example, here I typed the address Scientific Park Lleida and in Spain. Then I'm going to click on the save. We can see that it will navigate to this location in the map here as shown. And if we try to navigate here, it won't change the location because we specified directly that we want to use or type an address. If we want to, for example, use the map, we can press on it again. and we can navigate like here. It's going to show the street names and so on. So let's go to any location here. For example, let's choose this location and we can type a prompt or we can choose here also the LG tags. Let's try relaunching. So we're gonna see that it's going to get relaunched. So I guess this is it for the app, and thank you so much.
Hello, we are Mark and Joseph, and we are gonna show you Mahinour's app, that is GEMMA Touristic Tools. Let's go to its holidays. As you can see, that are the top 10 points of interest that you will see during the tour. Now, we are gonna show you the tour.
Hello everyone, my name is Siddharth Mudgil and I am an Android app developer from Haryana, India. And for GSoC 2024, my project is Gemini Touristic AI tool. And my project is an AI-based Android application for large-screen devices such as tablets that help user in assisting tourism using artificial intelligence. So for all the AI-based feature of my application, I am using Google Gemini API. So my app offers multiple features. So let me show you all the features of my application. So currently I have already opened my application. Let me close and restart application. So this is splash screen of the application. So as you can see, it is sidebar of application and it is also collapsible. Then this is about page of application, settings page where user can input Gemini API key, change themes, connection method, map style and map theme. Then user can connect from here, connect and disconnect. So there is some issue. I will fix that. Then there is Liquid Galaxy panel also where user can you clear KML, set slave, refresh and relaunching and other tasks. Then here is tourist place screen where user can generate different tourist place just by inputting their budget and environment they are most interested in. Let's say I want to visit Spain and I am interested in beaches and islands and my budget is $5,000+. So usually it takes about 5 to 10 seconds to generate a response. So let it generate. So it is generated, and if we click on any of the place, it will change to that place. So this is island. Then these user can also mark any tourist place as favorites. So I have marked and I can see here. So I have added one already. So I can remove also. Then user can also generate a budget plan for a location, like I want to visit Agra and New Delhi. My budget is $2,000 and I am planning to visit 4 to 7 days and solo. So it generated like routes, places, accommodation, additional. So it divided all the $2,000 in multiple cost the user can have. So another feature are like similar. So currently my app like don't have KML, so I am planning to complete it by the next week. So I have already added, but there are some issues. I will complete that. So that was it from my side. Hope you like my project till now. Thanks.
Hello, we are Basilio and Oriol, and now we will show you the Gemini ice controller that is made for Singh.
And now we're gonna go to Spain. You can see here we have Spain. We press the button continue and the app is loading. And for instance, if we go to Sierra Nevada, as you can see in the Liquid Galaxy, the app goes straight to Sierra Nevada. It shows a different place of Sierra Nevada. And we go to mountain side, and the Liquid Galaxy goes straight to that island. And basically this is what the apps
Show us the Gemini stuff, because this application is connected to Gemini,
yeah.
and this is coming from the Gemini API. So when you wrote here Spain, could you please write another place
For
like
instance,
Canada?
Yeah, I'm gonna put Canada.
Canada. You have Ernest.
If I put to continue,
Lower the keyboard. Then this is connected to the Gemini API. It's requesting the contents based on $500 budget and mountains, and then it appears several mountains. And then when you click on the mountain, the system goes to the mountain, and you can move it here, get more information, and many other functionalities.
Hello everyone, my name is Dalvi. I'm a computer engineering undergrad from India. I'm here to tell you about my project, that is the AI Touristic Educational Explorer for the Liquid Galaxy organization this summer. So my project basically revolves around getting to know about a city through the beautiful UI of the application and some mesmerizing visualizations in the Liquid Galaxy rig. So the three most important features which are to be considered while exploring a city are namely the historical things, the culture, and also the geography of the city and or the location, etc. And also one of the most important things which can be considered by a tourist are the points of interest, which is generally where the tourists travel to. So all this information is generated by a open source large language model, which is also known as GEMMA. So this open source LLM will be run using Ollama, and it will be inferenced using the Flask API server. This will be containerized into a Docker container, and it will help in the inference of the AI application. So this was the overall gist of my application. So moving on to the actual Flutter application, here is my application showing the home screen. So there are the placeholder cities along with the search bar where I can search for a city, let's say Paris. If I search for Paris, you can see that the map of Paris shows there, and there are these three flashcards showing history, geography and culture, these three tabs. The LJ rig also moves to the location, that is to the Paris city, and in the background the app has sent an API request to the local Flask server requesting data to be generated and sent to the Flutter application using the GEMMA model. Also, now as you can see, the data has been generated here. So here I have used a skeletonizer, which will give an animation effect. Also, there is an option to start an orbit, which will create a list of different points of interest across the city and send that data to the liquid galaxy ray to orbit around. As you can see, it has started the visualization. Here you can see the description of the given point of interest. On the right hand side, the actual monument which are supposed to be looking at in the middle, and the logos of the app on the left hand side. There is also, so while this is going on, I can also show you one more thing here, that is the extra visualizations. So like the historical facts, the etc., which I am going to be covering up. So those will be accessible here, which can be downloaded and later sent on. This is the UI for the drawer, which shows the liquid galaxy tasks, the connection manager, which can be used to connect between the different servers, AI server and the liquid galaxy rig, and all the other screens. While this is going on, you can see the Aritra triumph has been visible, so it is giving that description as well. So this is my current progress. Along with, I have also started building the KMLs for the different cities, like the historical maps and the city outlines, and the Docker file is almost complete. So this was my overall progress of midterm progress of my project for GSoC. Thank you.
Hello, I'm Josep and this is Mark, and we are going to show the app Touristic Explorer, whose developer is Manoj. As we can see, we have hit the menu, and we see that it goes well to the Liquid Galaxy. And if we search a place in the search bar, for example London, we can see that in the Liquid Galaxy we go there. I can see that it goes either up, and we can move a little to move in the Liquid Galaxy. Well, now we are going to search for another city. And we can see in the Liquid Galaxy that we go there. In this case, Jadu.
Hello Liquid Galaxy. Today I will explain my current project status. There are three main services: real-time fires from Mass API, historical fire perimeters for Catalonia, and forest fire risks from United States, okay, with precisely API. First, let's explore NASA API with live fire with different country. In this screen you can enter the country, and the screen will return a list of live fire with 4 hours delay. Okay. In the next screen, you can select the year of the historical fire perimeters, and after that the screen will return a list of historical wildfire for Catalonia. Okay, and after that you can send this to the Galaxy. And finally, in forest fire risk from United States with precisely API, you can input an address or select any location with maps pop-up, and after that the screen will show all parameters of forest fire risk, and you can send this to Liquid Galaxy. That's all for now. I will continue working on my project, especially in design and UX UI, because this is the bad bad design for all of screens, and this is I will focus on that. Okay, see you soon. Bye. Hello. Now I will test the Wildfire tracked app. Let's start demo. Let's open the app. In the screen we can see the collaborators. Let's connect to Liquid Galaxy. Perfect. Commands, buttons, and APK, custom APKs, basically. Okay. First, let's go to the first screen. This is NASA Wildfire. First, let's select the country, for example, Spain, and search. And this screen will show all live fires currently with 4 hours of delay. I will send this live fire, for example. We can see on Liquid Galaxy. We go to live fire with all fire information. If you want to orbit, let's select orbit, and I will send another fire, for example this one. And the Liquid Galaxy fly to new live fire. Perfect. Let's go to the next screen. Historical wildfire from Catalonia. I will select 222 and search. This has all of historical fire perimeters of this year, selected year, and for example I will send historical wildfire in Lleida. You can see all perimeter area for this historical wildfire, and the same, if you want orbit, you can orbit. Perfect. And finally, the last screen has USA Forest Risk for Precisely APA. I will input the address, for example, Miami, and this search, and this is all forest fire risk parameters, and I can send to Liquid Galaxy, and this shows like this: a perimeter area with color, filling color. I will fix this in the next versions, but if I select a real forest, will be bind. For example, this one. Do you Liquid Galaxy? Perfect. You can see the color because risk level has 14. Okay, and if you want to orbit, you can orbit with this button. Okay, that's it all. I will work hard with design and see you soon. Bye.
Hello, we are Mark and Jordi, and today we will show you the app Liquid Galaxy Wildfire Tracker. The developer of this app is Gerard Monsó, and the app connects correctly to the Liquid Galaxy. The app also sends data to the Liquid Galaxy, as we will show now. As we can see now, the app is going to a fire. This app gives you the option to see the last year fires, and if you want, you can also do an orbit to the fire perimeter. like we can see now in the screen. We can do another example here.
Hello everyone, this is me Rufaida, a GSoC 24 contributor at Liquid Galaxy, and I will be presenting the AIS visualization project. My project visualizes real-time maritime data extracted from the Norwegian Coastal Administration on Google Earth and Liquid Galaxy rig. This is crucial for ensuring maritime safety and aiding in environmental protection. Imagine you are using the AIS visualization app on Liquid Galaxy to explore and understand maritime activities in coastal region. Here is how you can engage with the key functionalities of the app. 1. Live ship tracking. 2. Detailed vessel information. 3. Historical vessel routes by playing back past routes of a selected ship over the past 2 weeks to understand navigation patterns. If you are curious about potential future routes, you explore the app's machine learning model. This model will be generating a fan chart on the map showing likely future routes based on historical data and current condition. You can select also 2 vessels on intersecting path. The app calculates the closest point approach and the time to CPA, providing insights into potential collision scenario. And finally, for a focused view, you can apply filters to view vessels based on their type and country of origin. One of the biggest issues that I faced is how to process the huge number of streamed vessels rendered on the map. I was able to solve it by implementing a cluster manager for marker by grouping every area into a single place mark that can be flattened to see all the vessel in that area. Thank you for your attention and waiting for more progress in the next phase.
Hello everyone, this is me Rufaida and I will be showing to you a quick demo for my project AIS visualization app and what I've been doing in the first phase for GSoC 24. The app starts by an About section having all the information the user needs to know in order to use the app. Then it has a side navigation bar having all the different options the user can select from, like visualization, collision, selecting a specific region for the vessel, in addition to Liquid Galaxy connection and Liquid Galaxy services. Let's get started by moving to the visualization section. Before using the app, you need first to register a client to the Norwegian AIS because the app uses the BrandsWatch service that offer the data in the app. So let's go to the credential section. You should register a client on this link. You have here all the description in order to get your client ID and client secret. Then you get the token. Once you get the token, the app fetched all the vessels that currently in the Norwegian Sea. As you can see here, it divides all the vessels depending on which cluster it includes. For example, if we open this cluster, you can have all the vessels in this area. We can see also that this area is very busy. It has like 1,000 vessels. You can see the huge number of the vessels here. Now you go to the visualization section. In order to see the details of a specific vessel, you need to enter its MMSI, or a better one, you can just click on the vessel, and then you have all the details for that specific vessel. But first, let's connect to Liquid Galaxy. As you see, once you are connected, the LG rig moves to the Norwegian Sea. It has a polygon for the area where the vessels can navigate. It also shows all the location of all vessels. This map on the controller also synchronized with the map of the rig. Like for example, you can zoom to a specific vessel. Let's zoom to this one. Move again to the visualization section. What I want to show again that once you select a new vessel, let's for example go here and open this cluster, then select this one. You can see here that the rightmost reg get updated with the vessel details, having all the section with all the details. Also, we can just show only the selected vessel on the map instead of all the vessels. And now you are viewing only a single vessel on the LG. Another key feature is that you can get the previous route of the selected vessel. For example, let's choose the start date. And now you have the route of that selected vessel. You can also play the route of that vessel, as you can see here. What I am currently doing is implementing the production model for a specific vessel to know what, to make an estimation on what track a vessel can do in a specific period of time. Next, I will be implementing the collision strategy based on this production model. Also, there is some feature the user can select. For example, filtering the vessels based on the country, on the type. And finally, he can select a specific region to show all the vessels in it. Thank you and see you in the next phase.
Hello, we are Basilio and Oriol, and now we will show you the ice visualizer that is made by Rafaela.
Here we can see, if I make zoom with my fingers, you can see how many shapes we have in different shapes. For instance, if I press that one, you can see the shapes, it shows here. Then with the zoom, we can see the shape. Then if now as you can see, we got the shapes in the 5 screen. If I make more zoom, we'll have it. Then if I reduce, we'll see all the shapes are in this zone. And if I check that one, we'll see many other shapes. And okay, that's all.
Hello Liquid Galaxy community, I am Aritra Biswas and I'm working on the Super Liquid Galaxy controller, and I am excited at the progress that I have made so far. Standing here at the midterm deadline, I think I have accomplished more than half of the things that I had planned for my application. And in that process, I have added functionalities that I didn't even plan for. I've taken methods that I did not even know were possible. And it has been a great learning experience for me. So far my application is a very custom way of interacting with the Liquid Galaxy rig. Of course, it can connect to the Liquid Galaxy rig. There's a screen where we can dynamically build KMLs in the app itself instead of going to any text editor. And there's a visual editor for that KML, and the user can upload the KMLs to the Liquid Galaxy rig to view their custom KMLs. There is also a maps-based controller where the user can control the rig with the help of a Google map, and it can also be controlled using voice commands. So I want my app to be accessible to a large audience, and I want it to be reaching in terms of accessibility. And I think so far I have accomplished it well. Other than that, I've also worked on beautiful KML visualizations such as a footprint algorithm for a path made of footprints. And so far, I look forward to the experiences that I will have in the future working on this application. Thank you. Hello everyone, this is the midterm demonstration for the Super Liquid Galaxy controller. So there's the starting splash screen and all the logos. This is the app dashboard with a simple navigation island, a planet selector, and the settings screen. So let's move on to the settings screen. It is a very simple settings interface where I can connect to my Liquid Galaxy rig. Their connection established. Then we have a tab with all the different various SSH commands. And finally a tab for the GAP5 Places API key, which is what I'm using for my application. So if I click here, it will validate my API key. There we go. Now that we are connected, let's move on to the first screen, that is the dynamic KML maker. So here we have an editor where obviously if we want, we can input things manually and we can add that element to my KML file. So there are 3 KML elements: placemark, polyline and polygon. Now there is also a beautiful visual editor. So if I want, I can move this marker and submit data. It will send all that data in my editor and I can add that element. Similarly, for polyline, I can use the visual editor as much as I want. If I want, I can add point and I can submit that data. All the data comes here and I add that element in my KML file. Now for the polygon, I want to show the full screen map. So if I want, I can just edit that as much as I want. Submit data, all the data comes here and I can add that element. Now there are 2 options. Either I download the KML file in my local storage as a .kml file, or I click visualize in LG, which what that will do is it will send that data over to my Liquid Galaxy rig. So as we can see, all that KML has been visualized. So here's the polygon, the polyline and the marker. So everything is working here. So let's move on to the next screen. That is the LG controller. So this is the maps controller. So as we can see, it controls the LG rig with the map. So it mirrors my movement here. If I want, I can zoom out and I can even move anywhere and it will mirror whatever movement I am doing on the map itself. Now, there is also a search bar. If I want, I can search up some place, say like Hara Maidan, which is where I live. Yeah, so it gives me and it zooms to that place. Now, moving on to the next functionality, that is the voice commands. So if I just move that, alright, so that is the voice command. So if I click here, zoom out. So similarly, there are a lot of basic commands like zoom in, zoom out, move up, move right, and stop. So it can also understand commands broken up, but that is the basic of the voice commands. Alright, moving on. Currently, I'm working on the tour management, where if I want, I can just select a place. So since I am near Kolkata, let me just select India and it will show me all the states. So Kolkata is in West Bengal. So if I select West Bengal, it will take some time and it should load a polygon over West Bengal. So yes, there, as you can see, all of West Bengal has been highlighted. So that is my progress so far, and I'm currently working on the tour management screen. Thank you.
Hello, we are Yash and I will show you the Super Liquid Galaxy controller that is made for Aritra.
And now we go to Liquid Galaxy controllers. And here, the app goes straight to this place, the laboratory state in Jada. As you can see, this is the laboratory, and now everything I do with my fingers, you can see the same thing there. For instance, if I go to, this the Cathedral of Jada, you can see here, and now the Liquid Galaxy is doing the same thing.
Hello everyone, I'm Mattia Baggini and this is the status of my project Space Visualizations for Liquid Galaxy at the midterm. In the past weeks I've been working on the Mars section, where I implemented various pages to showcase the Mars 2020 mission. This includes displaying 3D models, map of the path, and a general and technical description for both the Perseverance rover and the Ingenuity drone. The map is synchronized with the Liquid Galaxy screens, so every movement on the application will be replicated on the rig. There is also a section for visualizing all the photos taken by the rover. These photos can be filtered by date, cameras and the number of photos. In the future, user will be able to display them on a Liquid Galaxy screen. The photos are provided by NAS API. All the main parts of the rover and the drone are displayed both on the application and on the Liquid Galaxy screens, using KMS or balloons. Users can also learn more about the structure of the rover respecting the 3D model. The application also offers all the services that Liquid Galaxy needs, such as LG relaunch, set refresh, reboot or shutdown. In the next part of the GSoC, I will finish implementing the Mars section, and then I will start building the Orbit section, where user will be able to show and explore the today's most important Earth orbits. That's all. Now let's look at the application. Okay, so here we have our application. Let's start from the home page, where I can see two sections, one for Mars, one for the orbits. Let's first connect our application with the Liquid Galaxy. Here we have all the Liquid Galaxy services, but now let's see the Mars mission overview. In this page we can see some text about the mission, some dates. Here we can meet the Perseverance rover. In this page we can read some text about the rover, some technical data. We can interact with a 3D model on the left, and we can see the path on the rover in this map. This map is synchronized with the Liquid Galaxy, so every movement will be replicated. Now we can inspect the drone. Here we will see a 3D model of the rover. We can select any part of it, for example the wheels, the back, the camera. Okay, but now let's see the rover's cameras. Here we have a list of days. We can see the camera's position here. We can filter the days by date, photos number or cameras. But now let's select one day. Here we have a list of photos taken by the rover on that day. We can scroll them, we can select them, and we can explore Mars. Okay, now let's meet the Ingenuity drone. Here we have some text, some technical data. We have an interactive 3D model here on the left. We can see the path of the drone in this synchronized map. We can read more about the drone from the NASA site. Here we have some technical description and data. That's all. I hope you like the application, and see you soon.
Hello, I'm Josep, and here's Mark, and we are going to present Mattia's app, LGSB visualizations.
First of all, let's see the Ingenuity drone. In this part, you can read some information about it, but also you can access this website to see even more information. If you press this map, you can control the Liquid Galaxy, as you can see. Now we will see more things about Perseverance rover. You can also see information and control the Liquid Galaxy. There is also the website with information, but you can also see photos that rover has taken. But the most important part is that you can see rover's model. You can also press the different parts of rover, as you can see.
Hello everyone, I am Rohit, GSoC 2024 contributor at Liquid Galaxy. So I am here to demonstrate my project for the mid-evaluation. Though reaching this stage was not easy because I went to a lot of problems like connecting the real devices with Liquid Galaxy rigs, and it took a long time, but thanks to mentor Yash for helping me out, and will together resolve the issue. Along with that, the weekly meetings that held really helped me to enhance the application from the user perspective and added some more new layouts and colors, etc. And thanks to admin Andrew for keep reminding us about everything regarding the GSoC. So let's see my demonstration. Thank you.
So here I am with my application. This is LG AI Travel Itinerary, in which I am using Groq API for retrieval of the information and getting the response from different models as according to the user input. So let us explore this one. So first of all, I can show you this connection screen. If you can see, I am already connected to this screen, so I have IP address and everything added. Next thing is this is the home page where you can get a set of simple places, and when you click on any of them to explore, it will let you explore different stuff. So before that, I want to show you something else also. So this is the sidebar, and we can see everything like these Liquid Galaxy managements, whatever we have, clean slaves, then show logo, clean KML. So if I click on then clean slaves, so these are like when you click on clean slaves, so these are this will clean the slaves. Okay, so the rest of the things are the same. Like if you want to shut down, you can shut it down. So let me go through one more feature, which is add city. So when you click on add city, and let's say just select the model to GEMMA 7B, and I want to explore, let's say Delhi, then I'll click on explore, and we can see many sub points are generated. And if I click on this explore button, so we will be redirected to this map page, right? So here we are having different sub POIs that are listed on the left. So let's see now. When I click on this play button, and then you can see that the movement will start to happen, and it will rotate to different places. So you can see this starts to rotate, and we're getting the coordinates along with the KML, and you can see this also starts to rotate in the map. So both are synced with each other, and you can see this is the demonstration in the application, and this is on the Liquid Galaxy rigs. So when it moves, similarly this moves on the this map. So you can see this KML also. So this will generate for all the sub POIs as listed here. And finally, so that's all about the application. I have talked about everything, and yes, so I've added about the added city and the all locations. So you want to explore, just click on explore, and you will be getting the same thing as it was in the add city. So that's all for this. Thank you so much.
Hello, we are Jordi and Mark, and this is the app that we will show LGI Travel Itinerary. As you can see, they connected correctly to the Liquid Galaxy. Also, the app sent data to Liquid Galaxy. You can explore the different itineraries or the different cities or ubications.
Hi, this is Shivain, and I am a part of the GSoC contributors for the year 2024 in the Liquid Galaxy organization. My project is LG AI Fictional Traveler. As the name suggests, my project tells you the story of a traveler. What my project will do, it will ask you for a place that is a point of interest, for example Delhi, and in that place it will generate a list of sub POIs that would be the places existing within Delhi, and those places would be generated according to if they are closer to each other and things like that. Apart from this, the places that would be generated would be highly personal, that would cater to your personality, For example, if you are an introvert and you do not like crowded places, you just have to tell it that I am an introvert and I do not like crowded places. These are the places that would be generated would suit your taste. And the personality is not just limited to introvert or extrovert. It can be your profession, it can be your likes, it can be your dislikes, or anything else. So basically, since this is an AI generated story, your personality is limitless here. Apart from this, the features that I am offering, that I am developing, are text to voice and voice to text using Bark AI. And I am also providing the users with the feature of looking at the place that they are going to go using maps, and they can also play around with it. Now, the AI I have been talking about is GEMMA, that I would be running locally on Docker. Now, this app is being developed for the Liquid Galaxy organization, and this organization basically does synchronization between different rigs and does visualization of different locations based on the Google Earth application. So using this Liquid Galaxy, I would be visualizing those places that the user would be going and how they would be going. I would be creating tours, I would be creating images for the users to see and stories for the users to read using the visualization available in Liquid Galaxy. These are the logos that I have for the application. This is the warning for AI hallucinations, since we are using AI and users should know about it. This is the home page of our application. It has two saved locations, that is Delhi and Punjab. Alright, now we are gonna look at the about page of our application, and we have four things, that is Liquid Galaxy, GEMMA, developer, that is myself, and GSoC. Now this is the settings screen. It has theme options. Now we're gonna put the options to connect to our LG rig. Okay, it shows connected and unconnected if it's connected. Alright, and authenticated as well. These are the LG buttons. These work for LG. Okay, you can have some functions in it like test, clear, write, slave, etc. Okay, now I'm gonna show you. This is one of the save location, Delhi. These are the itinerary. Okay, the places that we can visit. These are the day-wise options. Okay, on which day you visit what, and we have some estimated costs. Alright, let's fly to some location, that is India Gate. Okay, you have the traveler story and the place, and as you can see on the LG rig, there is a picture of the place and some story. Let's look at some other location. Alright, now let's say for example we have Khan Market here, and it's a story and such. Alright, apart from that we have added. Okay, and now let's go back. This map is movable and user can play around with it, and this is the complete map option where user can go and have a look at all the places that he likes. And this is the generate option. You can speak here or you can type whatever you want. For example, we are writing California here. Okay, this will generate some places for California, and this is the result that we have. Okay, such as San Diego, Hollywood.
Hello, we are Basilio and Oriol, and we will show you the application of Shiven, that is
Fictional Itinerary. And here we can see the different cities of the app. For instance, if we go to Delhi, and we press, then we go to Red Fort. Yeah, then we can go to Delhi. As you can see in the Liquid Galaxy, the app goes straight to Delhi. And if we go to Umaru's home, the app will go straight to that place.
Hello, I am Davit. I'm from Catalonia, and today we'll be explaining how my project LG Agro Task Manager is doing. So well, my project consists of an app where you can store in a database the crops that you are planting, all together with their plantation date, transplanting date, and harvesting date. So then in the main menu you have a reminder of each crop and if there is a crop in season, you have a little table which says, hey, pumpkins are on season for harvesting, for example. Then you also have robots that you can add manually to your system, and those robots can do tasks in different fields. And then this is where GSoC comes in, right? Because whenever we want to do a task, we have a part of the world where this is being done, and we click in a button that says visualize task, and then we go to the field and we see a KML in which there is a little field demarked, and in the future we will also be able to see in a corner the remaining tasks for each robot along with their completion percentage. But this is the part that got implemented right now. I also am able to reboot the Liquid Galaxy and put on some basic info. As you can see there, it says David Mas, but we will see that more deeply in a second when I show you the app completely in the tablet. So as for the explanation, that's the current status of the app. Now let's go and see how it's doing on the tablet and the Liquid Galaxy. Okay, so when we open the app, this is what we will be seeing. This is a main menu with a temporary logo, the crops menu, the robots menu, and the settings menu. And here we have the planting season part. As you can see, it says eggplants, pumpkin, whatever. Because if we go to the crops menu right now, we have 3 different plants. Eggplants are on season for harvesting because we are on the 14th fortnight of the year, and it says from the 12th to the 15th. Pumpkins are in for we're on the 14th, excuse me, and pumpkins are in for transplanting because it's from the 13th to the 14th. But for example, yams aren't there because our current fortnight is not there. So if we want to see more details about a specific crop, we can click, and for each task we have a different table. In green is the fortnight where we must do that thing. In gray is the fortnight that we are currently in, and if it's in yellow, it means that we are in a fortnight where that task is due. We can also edit the crop down here, and we can delete the crop and add more crops. Now, when it comes to settings, here we have a menu to connect to the Liquid Galaxy, and here we have reboot, clear info, print info, and orbit around position. But yeah, we will connect here. Okay. And right next we go to the robots. As you can see, we have 3 robots: Davit, Pau, Hortensia. We can add more robots if we click here, and they will be added to the database too. We can add tasks to each robot, for example, watering, harvesting. And here we have watering simulating and harvesting simulating. And if we click, for example, on Davit and we click visualize, now it takes a little bit, but we will go to Saros in Catalonia, and we will be able to see the field where the robot is working. As you can see, it only shows some points. It doesn't show the delimitation correctly, but I don't know why that happens. And now if we go, for example, to Hortensia, visualize, it should be going to India. And yes, as you can see, that's the current state of my project. What left to be done is to add, for example, in that screen, remaining tasks or a current tasks list, changing the UI a little bit so it's more beautiful, because as you can see right now it's quite simple, and properly doing the logos and the KMLs. So well, thank you for listening, and I hope you find my work to be correct. Thank you.
Everything changes.